So I want everyone to go to this, to the course page, and then go to the section 2.1, which is practical data science, okay? And okay, so let's get started. So I want to start, I don't want to spend too much time on the theory. I would come back and talk a little bit about the theory of what is data science in general and what are all the elements of a good data science program for a company and what are all the skills required and so on. But now I'm going to just start with a simple definition. The idea behind data science is that now that we have a lot of data on the internet, within companies, even personal data, can we use computers and algorithms to extract information from this data? And then can we use this information to develop predictive power and or to develop a kind of artificial intelligence, right? And so all this excitement today about data science and AI is coming from the fact that we did a few experiments and we found in some cases that the availability of data made it possible to create intelligent behavior, right? Or more intelligent behavior. And the classic example for this is, for example, if you wanted to try to write a program that could translate from English to Japanese or English to Chinese or whatever language you want, then traditionally we thought that maybe one good approach is to understand what is the role of grammar and what is the role of translation and use dictionaries and all these ideas, write a program, logical program to solve this problem, right? And to some degree, this was the excitement of, the first excitement of AI was that we started to make some progress with this. But then we found that these programs became far too complex and we couldn't actually improve our results. And so we kind of gave up on this a little bit. So the second kind of wave of AI, which started, I don't know, say, let's say about 5 years, 8 years ago, 10 years ago, was this realization that if I took just all the documents that exist on the web, for example, where people have actually manually translated a Japanese document into English or an English document into Japanese, and I use that as a data input to a model. Then I use this model to actually do translation, right? So there's no human activity except to choose the right model, feed the data into the model, and then the model is going to create a solution that is going to solve the problem of translation, right? So there's an entire field here called machine translation. And we started to get good results, right? And then people got excited. And the second classic example here is, for example, the self-driving car. We started to get some progress in actually having a car not drive off the road and so on and so forth. So these are just two examples of what could be achieved. But clearly, a small bit of progress is not enough to say, oh, yeah, everything's going to work. And I'm on the camp that says we need a lot more work before this is all going to play out. So anyway, that's again, mildly philosophical, opinionated discussion, what is going to happen in 5 years, 10 years, etc. But for all of you, there is no doubt that many people have bought into this idea that we could use the data available for useful purposes. And almost every company, every college, everyone is investing in some way to create both a skilled workforce and to create jobs and openings, etc. Right? So for all of you, learning, understanding, and being part of this is probably a smart choice, right? It is where the future is. The only thing is that it needs a lot of effort and discipline to be good at this, and you have to figure out where you fit into the piece of into this equation. So I will share that pipeline, what are the pieces, who can fit where, what skills are required at the end. But now let's go and say, okay, whatever I said theoretically, let's make it all very concrete and practical.